Hi, my name is Ainul Azrin bin Kasim and I'm from CS2486B1.
Hi, my name is Mohd Luqman Rizuan. I'm from CS2486B1.
Hi, Assalamualaikum. My name is Aniq Ammar Ekhwan. I am from CS2486B1.
Assalamualaikum, I'm Haziqah Binti Hairudin and I'm from CS2486B1.
Hi, Assalamualaikum. My name is Khairunnisa binti Marion alias Muhammad Yusop. I am from CS2486B1.
So before we go any further, here are some background for the Starbucks and this project. So Starbucks is owned by Berjaya Food Berhad in Malaysia, and it is until today Starbucks has existed in Malaysia for about 20 years. Starbucks is known for their premium brewed coffee among the community in our country. So for the background of the project itself is, this project is developed using simulation model, which is arena simulation. Arena simulation is used to evaluate performance of the statistical accumulators such as total number of entities served, total queue times for entities, and maximum queue time for entities. So for our project, obviously our entity is the customers who enter the Starbucks. For this project, input is taken during peak hours and analyzed through arena and led to analysis and recommendation. Problem statement is an issue that could affect Starbucks performance. So generally for food and beverage industry, service time is the most essential, valuable and common things that the company should take care of and be their major concern. So here are the example of the problems that could occur or affect the Starbucks performance. Scope of the project is, first we're using Arena Simulation version 15.1, Microsoft Excel, a 12-hour simulation process in the Arena, and two types of main process, which is order process and pickup process. But bear in mind, due to several factors, this project or this simulation could only be implemented for Starbucks in Malaysia due to several factors. Basically, there are three main objectives of this project, which are first, to develop the arena model or the queuing system, second, to determine the performance of Starbucks queuing system, and the last objective is to determine the bottleneck of queuing system and suggest recommendation.
I will continue with the methodology part. Firstly is the data collection. We use hypothetical data that simulate 12 hours operation, which is equivalent to 720 minutes. The operation hours of Starbucks is from 10 a.m. to 10 p.m. from Monday to Sunday. We use input analyzer to find feed distribution. Initially, for the process of customer arrival, order process, pickup order process, and waiting time, we use a random number between as shown in the table. As for the distribution used in Starbucks model, from the input analyzer, for the customer arrival, we use uniform distribution. For order process and pickup order process, we use the beta distribution. And for waiting and dine-in, we use triangular distribution as shown in the table. Second one is the simulation process. There are a few steps in this process. It includes define the problem statement, design conceptual model, building simulation model using Arena software, verify and validate model, and experimenting the model. The model that is adequate enough can be documented and presented by using the assignment output. In the first step, define the problem statement in the Starbucks. We analyze that when this customer wanted to order, they may take too much time in the order process and pick up order process. Other than that, queue for a long time, so they will not prefer coming to Starbucks. Thus, this study want to analyze the system effectiveness towards the customer. The second step is design the conceptual model. In this part, the model is developed to be included in simulation model. All the components and constraints in the system will be constructed in a conceptual model known as flowchart. The third step is building simulation model using Arena software. In this step, we use software called Arena to implement the conceptual model constructed earlier. It begins by determining the model's flowchart, then building the basic model by dragging the create, process, decision, and dispose icon to the flowchart area. Then the station and route was added to proceed the animation process. Before continuing the animation process, the best fit distribution needs to be analyzed. The fourth step is verify and validate the model. In this step, we can verify and validate the model using the model difference percentage, which the value must be less than 10% to show that the model is valid. This step is important to produce an accurate model and to ensure that the model has zero logical errors. The next step is experimenting the model. A complete set of experiments is conducted to check whether any enhancements should be performed in order to improve the system performance. The appropriate simulation will be run to update the information required to make an informed decision and analyze the output from Arena simulation based on the assignment report.
For this flowchart system, it will become a guide to the flow that need to be included in the simulation model. First, it will start with the customer arrival. Then the customer will proceed towards the order process, and then after completing the order and payment process, they need to wait before pick up the order. After picking up the order, customers will choose whether to dine in or just take away their food or their drinks. If the customer choose to dine in, they will sit any table that is provided inside the Starbucks, while for the takeaway customer, they will leave the premises. After the dine-in customer is done eating or drink or hang out with their friends, they will leave the premises. That's all about the flowchart. There are 6 different modules that we'll use in this study. The 6 are create, process, decide, station, route and dispose. Each of this module has its description beside them in order to give audience information about what the function of each module. Here, we move to the flowchart in the Arena software. As I mentioned before, we use 6 types of modules. Firstly, once the customer arrives at Starbucks, the customer will go to the order station to continue the order process. At the counter, there will be 2 staff serving the customer for ordering and payment process. Next, after completing the ordering process and making their payments, customers will wait at the waiting area until the order call workers call out their number order or their names. Customers can choose either to dine in or take away after picking up their order. If the customers wants to dine in, they can sit at any tables that are provided in the Starbucks, while those who want to take away, they can leave the premises. When the dine-in customer has finished eating, they will also leave the premises. For the Arena simulation, it is run for 12 hours with 6 numbers of replications using 2-dimensional layout. It is used to validate if the process happening are the same with the real life situation occurring in any Starbucks in our country. So here is the animation for the Starbucks simulation model.
So I'm going to explain about the verification and validation. So after complete the simulation, verification and validation of the model need to be complete. So the model used the first approach of the validation simulation model, which is percentage difference between the model prediction and the actual observation. The validation process only involves the two main process, which is order process and pickup order process. From the second table, the order process is equal to 0.1513%, while the pickup order process is a 0.7663%, which is both less than 10. Thus, the model is considered valid.
Next is the analysis and result. It consists of three parts, which is summary report output, resource utilization, and experimenting the model. As for the summary report output, the data analysis is for the first replication. There are two processes involved in this Starbucks simulation, which are process and pickup order process. The average time for order process is 5.442 minutes, while for pickup order process is 0.5896 minutes. This shows that on the average, the customer only spent about 0.5 minutes until 5.4 minutes at the order counter and pickup order counter. As for the queuing for order, queuing for pickup order, waiting area and dining area, we can see that on the average, customer spend 0.225 minutes queuing before they place their order. And for the queuing for pickup order, they spend on the average 0.082 minutes. While for waiting area, the customer spend on average 7.6059 minutes, and the dining area, the average time is 39.493 minutes. And this value shows that the customer spent for about 7.6 minutes in the waiting area before their number being called by order call worker. This means that the model for Starbucks simulation is good since the customer does not have to wait or queue for a long time to receive their order. As for the resource utilization, there are three resources involved, which are staff 1, staff 2, and order call worker. And the highest average utilization is staff 2, which is 48.37%, while staff 1 47.37%, and order call worker is the least, which is 10.31%. Utilization describes how busy the resources during the simulation. Since we notice that in the current simulation model, there is no problem regarding the waiting time that is too long or queue time is longer, so we assume that in the future the Starbucks will expand their business and more customers will come to their store. Thus, we made an enhancement in order to improve the system performance. Firstly, we changed the distribution for the customer arrival, and secondly, we add another resources, which is order call worker. As a result from the improved simulation model, we can see that the average time for every process and waiting and queuing time will decrease. As we can see, for the average total time customers spend in the system, in the current simulation model, the customer spend for about 42.148 minutes in the system. However, when the improvement has been made, the total time has been reduced to 38.491 minutes. As for the average utilization, staff 1 and staff 2, the average utilization has been increased, which means that the staff have received many customers at the order counter. As for the average utilization order call worker, since we add another call worker, we can see that the average utilization is decreased, which means that order call worker job will be distributed accordingly. Lastly is the conclusion. Simulation assisting management in resolving problems through identifying analysis of the result by comparing the main processes, which are order process and pickup order process. It is based on the four criteria. Firstly, for the maximum total time spent, we can see that order process has the largest value, which is 11.9 minute time of customer spend. The second criteria is average time spent waiting in the queue. We can see that order process also has the highest value, which is 0.2254 minutes. Third criteria is average process time. It is also nominated by order process with the value of 5.6684 minutes. As for the utilization rate, order process has the highest utilization rate with the percentage of 51.44%. It means that for these both two processes, order process has the highest value for all the criteria, which means that normally the customers spend the largest time at the order counter.
Wallah.